Good morning. Okay, today is Monday, the 27th of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day and I stream it here on Twitch Monday through Friday. I continue to work on Basecode, which is a new programming language that I'm designing. And specifically, I'm working on the Bootstrap compiler, which is written in C++. And see, on Friday, I had started working on the inline assembly functionality. So I have a really simple test case file here. And there were a number of changes that were necessary to kind of get to the point where we could actually consume this and do something with it. The first was I added what I'm calling a raw block, which you could call it a raw string or a here doc. It's kind of the same idea, that the parser sees this and treats this very much like a block comment and consumes the content inside and passes that along. That's the result of the expression for that lexical element. And so that was one of the first changes that needed to be made. Then after that, we had to kind of plumb through the content of this refactored source file to support this refactored assembler a little bit to take a source file reference instead of a stream. And then on Friday, I started work on the state machine for the actual assembly source parser, and got up to the point where I needed to parse the operands on a mnemonic. So I can parse comments, white space, and labels. That's all working. And I can parse the mnemonic too, so that's the mnemonic code plus the size specifier. And we're verifying that, we get mnemonics that we know are valid. So now we're into the operand list here. I didn't really do much over the weekend. Early this morning, I finished defining all of the mnemonics in the interpreter. And essentially this structure is just a reverse lookup, the opcode as a name and as a mnemonic, and then that points at a struct which has the opcode enum type and then the operands that are valid. So the way to read this is that the first operand can be an integer register and it's required, and the second operand can be either an integer register or an immediate value and it's required. And I went through and did that for all of these. Noticed a couple of bugs in the interpreter actually as I was going through this process, so I fixed those. And then let's see, so that was pretty much all that was necessary there. And so then I started fleshing out started to define what the operand list state was going to do here. So there are 3 kinds of operand. I don't know, 4, I guess. There's, well, okay. There are registers. Those can be any of the special registers, so PC, SP, FP, the I registers or the F registers. We have immediate values, immediate numeric values. So these could be decimal, hex, binary, and label references. And to make numbers a little easier to parse, we're going to require the hash to mean that it's an immediate value. So decimal would be 1, 2, 3, 4, 5. Hex would be FF. Binary so, and I guess we could even do the same thing with labels. We could say that we need the hash in front of them. I think the easiest thing to do here first is to just accumulate tokens, accumulate characters until we hit a break, meaning we hit a comma or a new line. So if when we come into the operand list state, the top of the loop would have already read a token, read a rune from the source file. So we don't want to skip that. So if it's white space, we're just going to read the next and keep going. Okay, so if we come in here and it's a new line, we're going to break. Otherwise, we're going to get the next one. If it's not white space, then if it's a comma, then that's when we're going to go into the state where we actually interpret what we've collected. So we're going to create a stream. Called operand stream. And let's do create an array. So if we hit a comma, we're just going to take whatever's in operand stream and we're going to dump it into the list. We're going to reset our stream. So we need to know how many are required up front. There's a couple of so I'm wondering, I think maybe what I want to do here is I want to save our location in the source file, and then I want to do a scan. Because we need to know where to stop. And that's going to be, without looking ahead, that's going to be hard to do. Especially since we want to be able to switch back to a mode where we can capture these comments. So we know how many we need minimally. We push a mark and we scan the rest of the current line. If we find a comma, we add that to our count. And we reset our position. And if the comma count is less than the required operand count, then that is an error. We want to save the mnemonic name to So now we have our code that's going to validate the first validation pass, right? Hey, are there enough operands here? And we have a couple of special cases that we're going to have to come back to. They will slip through this check, specifically the branch instructions and jump to subroutine. They all have an encoding that is PC offset, which we're not generating that right now. We will eventually. And of course, if you're going to write assembly by hand, you might do that. And that's kind of it's a special case because that's one of those scenarios where by default, if you use an immediate or a label, which is an immediate, then your only one operand is required. But if you do the PC mode, then it's the first and second are required. So we'll come back on that because that's really going to depend on we can't verify that ahead of time. We have to verify that when we actually are doing the parsing. So I think we'll just have to handle those, especially, which should be relatively easy because the metadata around the mnemonic records the fact that it's a PC register it's expecting. So we could even add an extra flag or something to make it clear that it's like PC plus offset or something. So that's one case that this won't handle perfectly as is. But let's see how this fares. Okay. So let's look at our whip structure. We have a move, which is correct. That is the very first thing. The size is byte. We found the mnemonic, and the move mnemonic has potentially 3 operands. The first 2 are required. The last one is not. So our required operand count is 2. So now we're going to walk the line looking for comma. And then I just realized, okay, yeah, we're going to get an error because so we'll go here. A new line is essentially an implicit comma. And we want to stop here. We want to scan forward on the line from where we start until we hit, that's not going to work. That's not gonna work. Yeah, so what else could be on the line? Because those are the only two state changing tokens that we could encounter, because we don't care about what's inside of the operands yet. There we go. That's what I was looking for. So now this is the part we're scanning, which is great. That's what it should be. There's always one comma less than the number of operands. Okay, so now it actually did break out of this, but let's see what we get here when it does. So we should have, our string array should have 2 entries in it. That has 1, has I 0. Oh, right, because, so we don't need, this condition's not right. All right, so now, Okay, so we're hitting the semicolon. That's our terminal state. All right, now we have two strings. Hey, Slayer Darth. So we have I0 and we have immediate $FF. Perfect. So now we're going to break out of the loop, and then the next step is to add the code that will interpret those. And what we're going to do is we're going to yep, pretty much. And then just let's do state equal assembly parser state void space. Okay, so if we exit because we hit a comma or comment at the somewhere after the operands, we're going to go into the comment state, and if we hit a new line, then we just go back to the white space. Actually, no, that's not right. You want to go to the instruction state, but so then on the whip structure, when I saw the movie The Fly, the remake with Jeff Goldblum, the scene where he shows that he has a closet full of the same suit, I always thought that was a really cool idea. And so now I don't have the exact same thing, but pretty close. I wear plaid shirts, I have t-shirts, and I wear jogging pants, essentially. Black or silver. I would prefer black for everything, but I buy what they have, when I go to the store. My shoes, my shoes are Velcro because my ankles and my feet are really bad, and if I use laced shoes, I untie them eventually by walking. Doesn't matter, because my feet roll, and so I just use Velcro, and I don't have to worry about it. The Velcro shoes don't come undone. But yeah, I've had people say to me, aren't you a little old for Velcro? It works. Good. So I don't think we need that state anymore. I think the list is going to take care of those for us. And then in comment, if whip is valid, I drive a Honda Civic, so my trunk's fairly small. I don't frequently drive SUVs or anything larger. I think the biggest, which is true in my car as well, I think it's true in any of them, right? But in a minivan or an SUV, I guess you would get more. The idea is that you put your seats down, right? If you're going to be hauling something large, presumably, then maybe you don't have as many passengers, or at least that's the trade-off they decide to make. No. It drives me nuts. One of my biggest complaints right now is that it's very common. I would almost call them like monster trucks, but they're not. But it's a very typical thing to go to park somewhere, and all the cars around you, all the vehicles around you are these really huge trucks, pickup trucks essentially, but they're extra large. Their tires are the size of my entire car. They're just very large, and you're boxed in by them. So thank goodness I have sensors in the back of my car, and my car can detect cross traffic when I'm backing out, because if it didn't, often I would not be able to see. And of course the same is true if you're trying to turn out of, say, a parking area onto a street. If one of these trucks comes up to the left or right of you, you can't see around them. It's impossible. So then you have to yield to them because you can't see. It's really annoying. And honestly, like, those vehicles, they have to have the worst efficiency imaginable. I cannot believe that those trucks get more than perhaps, say, like in the most ideal circumstances, 10 miles to the gallon. And of course, the people who drive them like idiots, and they go way fast, a lot faster than they should. They drive very recklessly. I see the desire to have extremely large vehicles in the United States as a symptom, as a outward sign of some deep symptom we have in our country. I'm not quite sure what it is, but it's not rational thinking, because if they were thinking rationally, they wouldn't have those vehicles. Now, if you're a workman or, I mean, there are times when I think, oh, it'd be nice to have a pickup truck to move things around or whatever, but I wouldn't use it as my primary vehicle. And ironically, both sides of my family, they're farmers. My grandparents were all farmers. Their parents were farmers, and they had trucks, and they never drove their pickup trucks other than for farming purposes, because it costs too much money. They would drive cars if they were going to go somewhere. And of course, this is years ago, but even back then, right? Like, they wouldn't drive their pickup trucks. If they had to go to a grain elevator or something, again, but that's work related, right? They drive the pickup. Makes sense, because you might have to haul something. But yeah, if they were just going to go out, they never drove their trucks. But nowadays, we seem to be becoming caricatures of ourselves, because people are just driving these insanely large vehicles, and it doesn't make sense. At least it doesn't make sense to me. So oh yeah. If I try to park in the corner somewhere, it doesn't work. You would think that it would, but it doesn't. I don't understand. That has something to do as well with, like, if you could have a restaurant, like say some fast food restaurant that has a drive-through window, and they could be dead, but as soon as one car is in line, then everybody else will go there too. I don't know what that is psychologically, but it happens. I think it's the same thing in parking lots, right? If you park in a corner, then away from everybody else, then there's just, I don't know, there's something there that I don't do it, but I know other people do. It's like they see it and it's like, oh, there must be a reason they're parking there, and then they start parking next to you. You don't get it, but that happens. Is the U.S. government interested in phasing out gasoline and diesel cars? No. If the United States were interested in electric vehicles, the way that they would make you believe they are, then we would not be in Afghanistan, Iraq, attempting to get into Syria, attempting to get into Iran, trying to box Russia into a corner, and trying to piss off China, right? Yeah. If we were truly all about the green, we would not be doing what we're doing. It's the same thing as, don't get me started on ethanol. That was an absolutely horrific and awesomely stupid thing to do. Yeah, so I know I'll probably get the tinfoil hat award for saying this, but I think it's true nonetheless. If you look at what the major governments are doing, and you just have to stand back and ask yourself, right, why? Not, and you have to be open to the reality of what that why is. Why are we doing what we're doing in the world? And it has nothing to do with terror, has nothing to do with Islam or any of that nonsense, right? That's a cover. That's what sounds good. We're doing what we're doing because, let's just say the three majors, right? Russia, the US, and China know the clock is ticking. And that the natural resources, and it's not just oil, but oil is a big part of it, right? There's a finite amount left. When I say there's a finite amount left, I mean there is a finite amount of these resources left that we can afford profitably to extract and use in an economic sense. There's probably hundreds and hundreds and hundreds of years of oil in the earth, but we don't have the technology to get it right now. And we may never have that technology. The ROI on that oil, and it's not just ROI, it's EROI, right? It's the how much energy do you have to put in to get that energy out. And the EROI on oil right now is not that great. It used to be fantastic. EROI oil. Let's see here. Yeah, been declining, right? Do you just tell me what it is? Here we go, ERY. Here we go. EROI of coal is still pretty high. Oil it's below 25. Tar sands are super low. Oil shale is slightly better. Ethanol is really low. Biomass is really low. Yeah, so the net of it is we've gotten all the low-hanging fruit. And what's left is it's becoming very expensive from an energy perspective. And it doesn't, once you hit the point where you have to invest more energy to get energy out, it's over. So I always love it when you talk about oil shortages and things like that, and people will say, oh, boo, there's hundreds of years of oil. Well, yes, technically that might be true. Like there's hundreds of years of coal, technically. But how much of that can you extract in a positive energy scenario? So anyway, and here's the issue with alternative energy sources. Like, let's talk about solar. The issue with solar is, and I love how the metric that the media loves to push right now is the cost of the solar panel. And that, solar panels are getting cheaper and cheaper. Yeah, that's true. Although, a lot of that's subsidized right now. And a lot of the materials, the minerals and some of the exotic metals that go into solar panels, these are things that are on the endangered list as well. But even just setting all that aside, the issue with solar is not that, I mean, we could have panels that are 2 times as efficient as what we have today. It doesn't do anything, it doesn't solve the problem, because the issue is always base load, right? What do I mean by that? What I mean by that is when you go into your abode and you turn on the light switch, you expect the light to turn on. If it's really hot outside, you expect the air conditioner to turn on. If you need to cook dinner, you expect to be able to use the microwave. If your stove's electric, you expect it to work. This is base load. And you can't, solar's great at the point of receipt, at the point where the panel is. But our battery technology, our storage technology sucks. And we really don't have a good way to hold over, right, all those joules of energy so that we could use them at later time. And so again, because of the base load problem, we would always need something like fission, coal, or natural gas, something, right, that is running traditional generators so that when people demand power, it's there. And then if we could improve our battery and storage capability such that, wind and solar could be held over or could be held and redistributed, then that would be great. But we just don't have that technology right now. So solar is a spot source, wind is a spot source, and they can be effective in the areas where they're at, but that's it, right? You couldn't, if we had to stop using, fission, we had to stop using coal, we had to stop using oil, that would not be good. And so anyway, that's, yeah. To me, the green thing, electric cars, all that, I don't want to go so far as to say that it's a convenient smokescreen. It's not something I think that they intentionally are manipulating, but I think it's convenient for their purposes, right? It lets us believe that there is an alternative that we're working toward, but if you study physics for 30 days, you're going to understand that, yeah, these things can help, but they're not replacements. So, yeah, we have tons of wind farms here too, but again, we need some kind of, in the electronic space, in the energy space, right, the holy grail has been the supercapacitor. And some researchers have made slightly more progress in that area, but I think we're a very long way away from, people keep talking about graphene and carbon nanotubes and things like that. That would be a breakthrough for supercapacitors. But yeah, we're seemingly a long way off from that. Something that's production ready. And that's really what we need at this point. If we had something like a supercapacitor, then I would say we'd be okay. If we could scale up supercapacitors, then you could time shift solar power. So as an example, here in Utah, we have tons of sun, Nevada is the same thing. There's a huge solar farm not far from where I'm at. If we had supercapacitors, if we had the ability to time shift and location displace solar and wind, then that would be great. Because now you could actually move power from a place where you can collect it to a place where it has to be consumed. But we have very limited capability of doing that now with the electric grid. And it's the timing of the relocation of that energy is fairly tight. You know, it has to be moved essentially near instantly right now, and that's not going to be practical. Yeah, hydrogen's great. The issue there is storage. It's always been the issue. Again, it's one of these things where we just don't have the technology really. So, because hydrogen is the smallest thing that you can store in a pressurized vessel, and it leaks. You know, we don't have good enough storage vessels. Well, I think government knows more than, I think by definition, right? I mean, if you just take the United States, let's just think about just the US, because that's what I'm most familiar with. If you take the US and you say, okay, we have the NSA, the CIA, the FBI, DOD. DOD has tons of arms. We have the military itself, okay? And we have all sorts of other think tanks and analysis groups. My point is, the United States knows. And when I say that, they know. They're not now, how much of that information becomes public? Very little of it, right? But if you look at past confidential disclosures from the US government, it's clear that they know a lot about what's going on that they don't share. They don't share it because, well, for the obvious reason, right? I mean, if President Trump, had a press conference today and announced that, hey, every major spook agency and intelligence agency in the United States agrees that we have 15 years of energy security, and that's it. And that's only if we invade Iran, Syria, we prevent Russia and China from getting these resources. We have to go to war, we have to control all this. Even if we do all that, we have 15 years of energy security. Well, how does that work out? Not so well, right? People panic, the shit hits the fan. They don't want to do that, right? So instead they make up things that are plausible, right? Well, we got to save everybody. We got to bring democracy to the world, whatever the hell that means, right? So when you talk about the government not wanting to invest in these things, I think it's way beyond that, right? The government knows they're losers, period. They've done the research. Because listen, if the United States government, and when I say government, I mean all of it, right? All the spook agencies, all the military agencies, and these are agencies that work in extremes, right? They must prepare for existence in extremis. So it's not like, oh, they didn't think about this because they just didn't realize it. No. They think about these things. And if solar, if electric vehicles were winners, right, they would have been investing in these things long ago. It's kind of the same thing as, a lot of folks are pushing thorium salt reactors, which I think is cool. And I think we should probably be spending some time with that. But here's the thing, again, the one practical, real thorium salt reactor that you can point to was run by the US government. And using my logic, I have to think that they walked away with that with a bunch of operational issues, right? Yes, they had it running. Yes, it generated power, but they decided not to go down that road for some reasons. Now, a lot of people speculate the reasons they didn't go down that road was because they wanted to be able to generate plutonium for weapons, and thorium reactors aren't really all that good for that. That could be, you know, but at the same time, I know India and Japan, and now I just saw an article recently that China is, you know, heavily investing in thorium. But yet, if you look, there aren't really great success stories yet, and these countries are pouring money into it. So I guess my summation there is this: if the U.S. government isn't doing it, there's something wrong with it, right? And they know that. Now, those things that are wrong may be temporary, they might be fixable, or it might be they'd be okay for civilian use, but they're not okay for military use for whatever reason. But yeah, if we're spending all this time and money going after what few little pools of oil are left in, you know, the Middle East, then, you know, the cynical answer would be, oh, it's just money. And that's probably true on some level, but I also think it's just after you add up all the costs of infrastructure shift and everything else, there isn't a good alternative in the immediate case. Well, here's the thing too about hearing about cures for things. I mean, I'm diabetic. I can't tell you how many times people will come up to me and say, oh, I read this article about such and such, and, you know, they cured it. And it's like, no, no. You know, again, like if somebody cured cancer, if somebody cures diabetes, if somebody cures, you know, take your pick, you know, Parkinson's, whatever, then you would have such a huge, if it was true, you have such a huge media shitstorm over it that you would know that it's true, right? If you don't get that, then it's not true. It's just that simple. Because if somebody truly had cured these things, then yeah, you'd hear about it. Especially diabetes. I mean, I just met a young kid the other day, you know, who almost died. And, you know, if it's got something to do with kids, you're going to hear about it. What do you mean diabetes is not a disease? I'm not sure I follow. Oh, sorry. I don't always pay attention to those because they're not, yeah, I kind of filter those out because I don't see them as emojis. They're just letters. Uh, okay, so um, so there are two kinds. Well, this isn't even accurate. There are presently 4 different diseases, 4 different medical conditions that are referred to as diabetes. So right there, that makes things extremely confusing for folks. So one is what has been referred to recently, say the last 20 some years, I guess, type 1 diabetes, which used to be called juvenile diabetes. Of course, they dropped the label juvenile because more and more people were getting it at later ages, so it didn't seem to make sense to continue to call it juvenile diabetes. This version of the illness is because, for whatever reason, the pancreas dies. The portion of the pancreas that's responsible for producing insulin dies. Now, in some type 1 diabetics, there's small amounts of insulin produced. In many, there's none, right? The pancreas can't produce that insulin. And in that case, at least initially, type 1 diabetics are not not insulin resistant. They just don't have any insulin, hence why they have to either take shots or use an insulin pump. But because there's no automatic feedback there, they have to check their blood sugar manually. They have to manage their insulin dosing manually. It's a very rigorous and grueling existence. There is a variant of the type 1 diabetes, which is 1.5, they'll call it. The other term is LADA, or however you would say it. It's latent adult onset diabetes, which doesn't really help, but that's what they call it. It's essentially type 1. They don't understand why it's delayed. They don't understand, they just don't know, period, right? They'll say they know, or they'll say they understand. They don't know. Type 1.5 diabetics are essentially the same as type 1 diabetics. Their pancreas ceases to produce insulin naturally, and they have to supplement with either shots or with a pump. So then where you get into confusion is the type 2 diabetes, but really there's 2 variants of that, it seems. One is you don't hear about this too much, but there is a medical condition called reactive hypoglycemia. And reactive hypoglycemia is distinct from all the other kinds of diabetes, but it does seem that there's more research that's being done that's showing that some subset of the type 2 diabetes population they're actually people who suffered from or are suffering from reactive hypoglycemia, and that eventually becomes type 2 diabetes and or a form of it essentially. And type 2 diabetes probably needs to be renamed. It needs to be called insulin resistance or severe insulin resistance disease, something of that nature, because that's really what it is. Now, here's the reason why type 2 diabetes is linked back to diabetes at all is because eventually most type 2 diabetics become type 1 diabetics. They become obligate insulin users anyway, because at some point their pancreas burns out as well, or becomes, while it might produce more insulin than a type 1 diabetic, it's still insufficient to manage their blood glucose levels. So they will, again, become obligate insulin users. So the other category of type 2 is just that, right? And this, I think, is just like type 1 diabetics, their pancreas fails for some reason, and there's all sorts of theories why that happens. Some people think it's infections that cause it. Some people think it's autoimmune. Who knows? But I think in the other, so there's the reactive hypoglycemic camp that become type 2 diabetics. And then there are the folks that are just born with muscle disarray. And so there's a variety of categories of genetic mutations that cause the muscle is functional, but the structure of it is not normal. And because of that, most of the ability of the body to absorb insulin is in the muscle, especially the leg muscle. And there was a really interesting study, I'll have to find the link to it, but the gist of the study was they showed that they could predict this second category of type 2 diabetes like up to 10 years in advance by just biopsying leg muscle. And because the defect can be observed in that large muscle mass very early on because it's related to the muscle, right? It's just not able to function properly and absorb insulin like it should, insulin like it should. And so if you look at somebody who's really, fit and metabolically healthy and they're very muscular, this second class of type 2 diabetes, it's very difficult for that group seemingly to be able to recruit energy properly from glucose into the muscle and then have that whole cycle work properly. And this is someone who's had the disease their entire life. I'm a type 1, I'm insulin dependent. It's unfortunate that the medical community chose to use the same name for all these different things, just because they all kind of relate to blood glucose regulation. It's laziness, unfortunately. But here's what I would say. Nobody who has diabetes did it to themselves, right? Nobody asked for this. Nobody, whether you're young and your pancreas kicks out, or you're in your 20s and your pancreas kicks out, or you're in your 30s or 40s and you become massively insulin resistant. Nobody asked for that. And here's the thing, right? We love to blame people. We love to say, well, they overate. But here's the thing. Your body regulates that, right? So ask yourself this. The people who are ideally shaped, don't have the disease, they're able to manage, their body is able to manage caloric balance for them, right? And you would just say, oh, well, it's their willpower. They're not lazy and fat and, they just didn't do it to themselves. Well, okay, maybe, but what if you went the other way? Because we all know people who are skinny, who never seem to have any problems, and they can eat truckloads of sugar, right? In fact, I would go so far as to say I know people who they never have these issues, and you always see them running around with a soda or something, or a frappe double latte mocha half-calf piece of crap from Starbucks. So they're drinking 1,500 calories right there, but it never seems to impact them. And I would argue it's because those folks, their regulation system is correct, right? They don't have to work at regulating their body mass. They don't have to work at regulating their energy balance. Their body does it for them. These people who have this disease, or whatever variant of it you wish to pick, they don't have that ability, right? Their body does not do that for them. And therefore, then it does become a conscious thing. And I'll tell you, your conscious mind is not capable of controlling millions of years of evolution, right? It just doesn't work that way. And I didn't mention this, but the irony is that most type 1 and type 1.5 diabetics end up having both. They end up as type 1 diabetics, and they have some level of insulin resistance because they can't manage the disease perfectly. You can't, again, that's what I'm saying, no matter how fancy tools we create to manage our insulin intake and balancing that with, the amount of carbs we're consuming, it's not the same as the body doing it internally. You're always going to be off. And, if you do the math, if you're 50 calories off, give or take, every day, which is essentially one potato chip, right? Or, I don't know, an apple. An apple might be slightly more than that, might be 90 calories. You're going to gain like 30 pounds in a year. That's how precise, the regulation has to be. So then what happens is you have a type 1 who's been a type 1 all their life, or most of it, and when they get into their later years, they become insulin resistant, on top of the fact that they have no endogenous insulin production. Yep, we want to blame everything on, well, we don't want, my theory is this, right? We all have so many problems to deal with for ourselves that when we're faced with something where we realize that that's not really an individual fault, that's something that we have to concern ourselves with, we want to push back on that. People want to say, I don't want to make that my problem. They did that to themselves, they're fucked, right? I don't care. I have my own problems, I don't want to deal with theirs too. And of course, this comes back to other things that I've talked about before, right? People don't feel secure, the economy for a lot of folks is not doing that well. And people, when they don't have that sense of security and consistency, then it's very difficult for them to say, oh, that's, you know, that's something that we should all be helping with, or understanding that, you know, maybe we all need to pitch in on these things. It's just much easier than to blame individuals, and, you know, which I always find interesting, because how's a 10-year-old kid, right? Like a 10-year-old kid, they didn't do it to themselves, right? I'm sorry, it just doesn't work that way. But believe me, man, they will act like they did, and they'll tell the kid, oh, you just, you know, stop drinking those sodas. That's why you know, that's why you're sick. You drank all those sodas. Yeah, I can tell you right now, like, I don't take the insulin I should be taking, because it costs $1,500 per vial. Oh wait, that's not right. It's now over 2,000. Sorry, it's over 2,000 per vial here in the U.S. So I take an older insulin, which doesn't work as well, but it doesn't cost as much. Metformin. You know, metformin, there are two variations of the drug. There's the original formulation, which has a tendency to cause massive gastrointestinal distress in a lot of people, including myself. And so I can't take that version. For a number of years, I took, you know, 2,000 milligrams of classic metformin, and I would divide it up throughout the day. But eventually my body caught up with that, and it doesn't work. I can't do that anymore. Well, there's a variant called glucophage, which is a 24-hour release, extended release variety, which, at least for myself, eliminates all the GI issues. And from what I hear from others I talk to, it also helps them. That medication, the last time I looked, the pricing was $3,200 for a 30-day supply. That's insane. And this is a drug. I mean, all they did was put like buffers and you know, whatever they put in it to do the extended release. So okay, if standard metformin costs $30 a month, put an extra $100 on there for your fancy 24-hour patent pending release thing, and you're making pure profit, right? No, let's charge $3,200 for a 30-day supply. Yeah, and I'm sure, like, if I were to go to Canada, I could probably get glucophage for, you know, probably $30. Or India, I probably could get it for $10, which, okay, what's the difference? It's the same thing. Yeah, and, you know, there's all sorts of other, I've tried everything too. I've tried lots of other things to compensate for, you know, lower quality insulin, and yeah, they're all massively expensive. Pretty depressing. Yeah, so if I was, and this is just for one issue, I have others. If I were to spend all the money I should be spending on the medication I'm prescribed, cash pay, it would be $6,000 roughly, just for that per month. So yeah, And insurance, yes, glucophagia pills. They're, you know, little white pills, not little, kind of slightly larger than normal. Again, glucophagia is basically metformin. It's just an extended release. Metformin ER. That's 1,000 milligram. Yeah, this is the 24-hour version. So let's see, Good RX. Let's see what they cost today. I haven't checked in a long time. Oh, here we go. Metformin ER, Glucophage XR. This is the generic. So Walmart actually, no, this is a lot lower. That's good. Yeah, actually I should go to Walmart today. I'm gonna leave that open. So yeah, that's good. I don't know what happened. $290. Yeah, that's not bad at all. Hot damn. I'm gonna go to the pharmacy today. Well, now I'm curious. Wow, that's a lot better too. Oh, ouch. Holy cow. That's back down to what the price was. Oh, okay, no, there's the estimated cash price. It's because of their discount. Damn. That is still insanely expensive. So what if I do a carton? Yeah. Oh, those are pens, though. So I would need to... Yeah, that's still better. See, the problem is, yeah, I'm looking at Good RX, and Good RX is you get these coupons, right? And they're like one-time use type deal. So, I mean, these are good prices. This is a lot better than what it's been recently. But, you know, I use the coupon and then a month later, the price changes, right? So, but yeah, I'll definitely be making a trip to the pharmacy. Got to get it while I can. The one thing about insulin that's not too bad, like if it's cheap like that, well, cheap, I can buy it and I can refrigerate it and it lasts for up to a year as long as it's refrigerated. And you don't, obviously you don't open it. Once you open it, then you've got 30 days. Hey, Cyanox. Okay, so now what we gotta do, we've got our operands in the list. We're gonna walk the list. And if the operand string is, if the first character is the octothorpe, then this is a numeric literal. You know what we should do? Yeah, it's coming along. I'm in the process of parsing the operands here, and I've got the basics of that in. Now I'm just dealing with the actual operands and converting them into their type, essentially. So, got registers, immediate numbers and labels, and I don't know if what I'm doing really would be similar to GCC. Like for example, I'm not supporting single line. I mean, I guess you could do one instruction if you wanted here. Oh, I refactored that one thing and I forgot to finish. Yeah, mine's not quite that fancy yet. Will macros be visible across inlines? You have to specify what you mean by macro here, because Basecode doesn't have C or C++ macros. There's no preprocessor. However, with metaprogramming, you can pretty much do anything you want at that point. Oh, yeah, this assembler doesn't have macros at that level because, again, the idea is that metaprogramming will let you do whatever you want there, so you could build stuff around all that. Yeah, no. My inline assembly doesn't do this yet. This would all be something that I would build on top of the basic stuff with the metaprogramming. So I don't have this yet. Alright, so all I gotta do, so whip, we've got the code, we've got the mnemonic size, and then operands, we have register, and then this is immediate and 0. Okay, so now I'm going to do this part. And our token already does this. Yep. Very good. Okay. So that works. So now we're parsing this, we're parsing these. This is being recognized as a register. This is being recognized as a hex literal. So now we should be ending up down here in instruction. We set the valid flag here after we've built up the operands based on whether or not the sizes match, or the counts match, I should say. So then we're going to end up here, and okay, so that builds our instruction encoding. And let's move these to public. Right. So after an instruction, we want to go back to white space. Interesting. Okay. Didn't get to. Oh, well. Yeah. We have to reset our work in progress structure here. Okay, so we just added the first move instruction. So we just did this. Okay, so we hit a comment. No, we hit. Okay, so we're gonna go to mnemonic. right. So it's parsing all the parts. All right, I'm gonna take a really short break. We'll come back, we'll review this. let's look at this. So in the interpreter header file where the mnemonic structure is, I added a function on that struct that goes through the operands and counts up those that are required, because we need to know how many operands we should minimally have. On instruction block, I just moved the declarations for these methods up into a private block because we need to be able to call them from the assembler. Add the header file to the assembler header. Also added a helper function that takes a block and then gets a current entry. And what that'll do is if there is no current entry, it'll make a memo and then grab that and return it. So then inside of our state machine here, I got rid of the operand and directive param states because the lists just are going to take care of that. I added a code string to the work in progress structure and a valid flag. So as we're building up a mnemonic, once we get to a point that it's valid, we toggle that flag. In comment, since comment can go up to a new line, and a new line is a trigger for creating an instruction, if we have a whip structure that's valid, then we go to the instruction state. Otherwise, we go back to the white space state. Just refactored label to use that helper function. I also refactored comment to use that same function. Mnemonic, instead of using a temp string here, I set the code on the work in progress structure. Hey, move. Yeah, so these are just changes because I switched to that field on the structure. Then for our operand list, we get the required operand count, and then we scan through looking at commas to get an idea if we have roughly the right number of operands here. If not, we get an error message. And I've got a local helper function here that adds things to the list and clears out the work stream. So then we go into the parsing loop, which we're looking for commas. We hit a comma, then whatever's in the accumulation stream, we add that to the operand list. If we hit a semicolon, that means we're going to transition to a comment state, which means we're at the end of the instruction. So we add whatever we have accumulated. We know we're going to go to the comment state. This is terminal, so we break out of the loop here. Otherwise, we add whatever the current rune is to our stream. If we get a line break, we add whatever we have accumulated to the list, and then we know we're going to go to the instruction state, read the next rune, and just keep going until that finishes. Then at this point, we have in the operand strings array, we have strings that need to be further parsed. So, and we know we have special characters that kind of indicate what they are. So if the first character is a $, then we know it's going to be a number. So then we look at the next character and say, okay, is it $, percent, at, or is the next character something other than that? And then we grab the right substring here and we set the radix on the token. I'm reusing the parser token because it already handles a lot of this. And then I can just ask the parser or the token to parse that and give me a value out. If that fails, we get an error. Otherwise, we create our instruction encoding and our operand encoding and put that in the list. If it starts with an I, then it's an integer register. If it starts with an F, it's a float register. And at the very end, we say, okay, this instruction is valid if the number of operands we have matches the required count. And then for the instruction state, we create an instruction and we just basically copy everything that's on the whip structure over to the new instruction and we add it to the block. Then we reset the whip structure and we go back to the white space state. So that looks good. What's left then is directives. And that should give us a simple but functional inline assembler. Now, there's another issue I'll have to figure out, and that is the point at which this is operating in the cycle, in the compiler cycle. We don't have a block yet, right? A lot of the, because we haven't gotten to program emit. So I think what I'm going to have to do is I'm either going to have to pass in the block here or probably just pass in the block would be my preference, I think. Because right here we're creating one, but what probably should happen is, yeah, somehow we have to get that block back to the compiler. So on session, yeah, because this is all happening here before we've done any of this stuff. We don't get blocks. We don't start getting blocks for the actual compiled code until here. So yeah, somehow I got to figure that out, because we aren't going to see the content because it's never getting merged into the other blocks that are being created. So I got to figure that out. And then for directives, I think I'll just move, I think I'm going to move the metadata stuff here. Like so, this whole bit. Because this really, the terp doesn't need any of this to function. This belongs to the assembler. So then in the header here, I'm going to create another set of structures in the map for the directives. It'll be much smaller. And then the directive and directive parameters will work pretty much the same as what we did with instruction, except yeah, these will all just be raw data. Make sure I didn't break anything. Okay. So let's take one of the operands off here. Okay, so I moved all the assembler related metadata over to the assembler header file. I had put it in terp just because that's where the original source data was, but really these structures belong to the assembler. So these all came in here, and I'm going to be creating companion structures for directives. And then there's really two things left in the assembler itself. One is handling labels, which is really just a special case here. So when I get down to here, I need to say, okay, is operand string 1 is alpha or is it an underscore? Then we're dealing with a label. Otherwise, we're dealing with a number. So that's one thing. And I might have to refactor. I definitely need to refactor this because the encoding for the label is a bit more complex than just for the pure numeric. So I need to shuffle some things a little bit for that. And then the other thing are just the directives. And yeah. Got a couple minutes here. Oops. Are there lots of manga artists on Twitch? So there's the definition of our directives, such as they are now. And a little bit different from the mnemonics. So we can specify what size is valid for the params for this particular directives. Like in the case of the section directive, oh, I forgot a line. This can be up to a byte. Nice. Spell it. Right, so that basically what we're going to be validating here is whatever parameter is specified following the directive, it has to be no larger than a byte. The repeating flag indicates that it's okay to have a comma separated list of values. So like in the example of a line, you can only specify one alignment number. Section, you can only specify one string value. But for the data directive, for the reserves, I don't think repeating makes a lot of sense. Perfect. So that's good. All right. Nothing should change, but we'll just verify. All right. So included the boost variant header because I created a type def that includes string and a 64-bit unsigned integer because those are the two kinds of parameters we have right now. So we're going to end up with a whip type directive structure, and we'll need to use this for that. We have our directive types, which right now are section, align, the data definition, and reservation directives. And so a directive can have a size limit, the type, and then the list of parameters that it expects. And we just have our map from the name to the directive structure. And then we have our lookup helper given a directive code. We look up our directive, return back a pointer to that structure. And yeah, so then the next step will be to wire that in to the parser. So I will definitely finish that today, and I'll figure out the instruction block stuff is kind of, it's been in the back of my mind to refactor it anyway. I'm using a stack for them, and I'm not really sure I need to do that anymore. I don't know. I gotta think about that. So probably between the issue with the assembler needing to get blocks back to the compiler so that it can pass those in and do something meaningful with them, and just I need to review this and see if, I don't know. Again, I'm not really sure. This kind of started because my early passes on the code emit stuff was all recursive in the element tree, but then I started refactoring things into, so program now kind of procedurally drives a lot of the code generation. There is still some recursion, but it's localized. Yeah, and like instruction block, who's creating the blocks, and yeah, I think that's a little bit different than it used to be. So yeah, I got to think about that, and probably in that process I can figure out how I'm going to tease out a mechanism so I can communicate the list of blocks. Because if you have multiple inline assembly blocks, right, they're going to all get processed ahead of other code emit. Yeah, so I gotta think about that. But yeah, that's what'll be on my plate on and off today. And then tomorrow, I think I'll probably be able to swing back to the intrinsics. I think I have a pretty solid idea of how that's gonna work now, and it should be pretty easy to get those in place. And then once we get that done, then we'll swing back to the type alias stuff. I think I know how I'll fix that. And yeah, so that's kind of roughly where things are at. Let's see if we can find somebody to raid. Dev. From 0 to Vulkan Quake 3 in Haskell. That's interesting. Warning, messy development, hardcore something. Bash dude. Making a space combat game. Oh, the Haskell guy stopped. Looks like it. Oh no, I went right by it. Yeah, let's... Oh, Charles. Let's read this guy. Okay, we're going to raid O. Charles here, who is working on some cool stuff in Haskell. I'll be back tomorrow at 5 a.m. and we'll pick up wherever I leave off in the saga of compiler creation. All right, everybody. Thanks for dropping by. Have a good day. See y'all tomorrow. Bye.